Yan. So ito naman, ito yung sa unang single phase. Ay, awit. Yan. Tapos, ito yung sa unang single phase. Okay? Tapos after that, yung pangalawang single phase ito, no? Lagay ko sa gitna. Ayan. Yan. Ito yung pangalawang single phase. So, ibig sabihin, dito, ito single phase ka dyan, ito single phase ka dyan. Tapos, bali dalawang transformer siya. Tapos after that, this one, lagay natin dito 50% tap. This is 50% tap. Ayan. This one is 50% tap. Okay? Tapos, ganito yon. Ito yung unang terminal ng three-phase. Okay? Ito naman yung pangalawang terminal ng three-phase. Okay? Yung pangatlo, ganito yon. Teka lang. Ano ba yung cosine 30? Cosine 30. 866, ayun. Kasi floating, ay ano ba to? Floating kasi siya. So ngayon, dito lang yung pangatlo niya. Yan. Okay? Wherein, ang tapping niya dito ay 86.6% tap siya. Okay? So ito ngayon, phase A, phase B, and then phase C. So ito sa cosine 30, sine 30, tapos ito naman yung sabihin natin, no, to, ba't ito itsura? Uy! And the other one, yan. Yan. Where was I? So, yun na yun. So, this one is dalawang single phase. Ito naman yung nag-iisang three phase. So, ibig sabihin, pwedeng dito galing papuntang dalawang single phase or dalawang single phase papuntang three phase. Okay, so that's the Scott T connection kasi pa letter T siya eh. Ayan, sige. Wala kasi itong extra drawing eh. Ayan, ganyan na siya kagad. Ganyan ko na din drawing. Oh, kasi tandaan niyo yung tapping na sinasabi, ito yon. Ito yon. Yan yon, no? Tsaka ito. Ayan. So 50% tap dun sa winding na yon, dun naman ay 86.6% tap dun sa winding. Next to it is this, the instrument transformer. This one, itong nasa left side, is what we call the current transformer. This is the current transformer. Sir, pilot na answer. Ay, opo, ito. The correct answer is C, the Scott connection. Okay? Yan. Yan. Okay? So ito naman is, the first part is the current transformer. And this one is the potential transformer. So ngayon, ang tawag doon, mechanism ng current transformer is this. Ito yung conductor mo, ito yan mismo. And may chances kasi that malaki yung current niya, so hindi na advisable for us to connect an ammeter there. It's not safe. Kaya ginagawa doon, may kinaklamp, pagka-clamp, no, ito yan. Yung current dito will be the primary winding. Tapos the secondary winding is nasa clamp. So let's say ito na yung line current. Tapos maraming turns sa secondary. So after that, doon na-connect yung ammeter natin. Gagawin natin, pagka-read ng ammeter in small scale, no? Tawag ko dyan, gamitin natin yung transformation ratio nito, yung A. Okay? Then saan natin makukuha yung actual reading. Okay? For the voltage, then ganun din. No? So, hindi advisable for us to connect the voltmeter here ng diretso kasi malaki yung voltage. Now, ginagawa doon is may potential transformer or voltage transformer, tapos yung kabilang side is nakakonect sa voltmeter na mababa lang ang scale. So again, pagkakuha ng reading dyan, then you have a transformation ratio there, and that will be your reading. Okay po? So sige, tingnan natin kung paano siya ginagamit. So let's proceed here. In measuring transformers, instrument transformers are used in indicating and metering. With protective devices, they are used for, tandaan yung word na to with protective devices ng mga instrument transformers, aside from indicating and metering, they are used for relaying. Okay, so pag protective devices na, it is now related to the relaying na yon. No? So, ganun ang setup niya. Okay, so that's for number 39. So let's proceed with this. Number 40, it says there, a three-phase Y delta connected 50 megavolt ampere, 345 down to 334.5 kilovolt transformer is protected by the differential protection. The current transformer on the high side for differential protection is 150:5. What is the current on the secondary current transformer? Okay. So ano to, tandaan nyo na pagka current transformer, di ba, ang transformation ratio natin for transformer is baliktad, IS over IP siya. Pagka nasa transformer na siya na instrument, IP over IS na yung A natin. Okay, so to make a point, ganito yon. Sabi dito, no, it is connected 345, paano siyang Y delta. Okay, so may tanong, what is the current on the secondary current transformer? Ang kunin natin is the current in Y, no? So naka-Y kasi siya. Tapos the second one is the delta. Okay? So ngayon, the current transformer is on the high side. This is the dito siya kinaklamp, no? Dito siya nakaklamp. Yan, diyan sa part na yan. So ibig sabihin, ang nakukuha niyang kuryente is your I primary. Okay lang po. Ang hinahanap niya, what is the current on the secondary transformers? Ibig sabihin, yung current that is in the secondary current transformers, which is Doon na yun sa secondary nito. Okay, sorry. Yan, hindi pala doon, no? So ngayon, ganito gagawin natin. Let's compute first the I sub P. In primary, we have 50 MVA times 10 to the 6 all over, ano to, no? Y to, no? Square root of 3 multiplied by, the voltage there is 345 kilovolts times 10 raised to 3. Ayan. Wala naman, power factor, so siguro magnitude lang din talaga. Okay? So now that becomes, siguro no? Hindi, sure yan. So now we have 50 times 10 raised to 6 over square root of 3 multiplied by 345 times 10 raised to 3. Okay, so we have 83 and 67, no? So 83 and 67 amperes. Tapos, so this will be our value ng current for that one. Yan yung same na current na magfo-flow dun sa per phase kasi ang current nyo sa line is the same as your current per phase, so IP phase. No? Ngayon, proceed tayo with the secondary. For the secondary itself, ito yung setup niya. Ang A natin is IP over IS. Uy, ano to ha? This is for current transformer lang. Okay? Hindi siya yung pang, what do you call that one? Yung transformer talaga, no, na ginagamit sa operation. The IP there is 83.67 all over A. What was the A there? 150 over 5. Okay? So IS now become equal to, i-divide natin ng 150 over 5. So we have here 2.789. 2.789 amperes. Kaya lang kasi, this time, pag sinabi nyo kasing IS, it is what? Yung na-transform in the delta side na per phase. Let us remember this, no? Na pagka nagkaroon tayo ng transformation ratio, laging phase-to-phase siya. Phase current to phase current. Kasi hindi naman siya matatransform ng line-to-line eh. Ayun. Ibig sabihin, ang hinahanap niya, the secondary current in anong tawag ko dito? In current transformer is IS prime, which is 2.789. When we know it, we multiply it by square root of 3 para makuha natin yung sa per line. Okay po? So, ngayon, 2.789 times square root of 3, we have 4.831. So we have here IS prime (4.831 amperes. Okay, so that's it. So, letter D yun. So letter D yun. So tandaan natin, when we use this is phase current to phase current. Okay, hindi siya laging line. So ngayon, syempre, pag nag-clamp ka sa line yon, so galing siya sa line. Ayan. So gagawin mo, ita-transfer mo siya to phase, tapos ita-transfer mo siya to line. Ganon yun. No? So that's what we will do pagka meron tayong mga ginagamit na current transformer. Okay? So sige, copy nyo lang yan. Okay? Next to it, number 41, a 20 to 1 potential transformer is used with a 150 voltmeter. If the instrument deflection is 118, calculate the line voltage. Ito madali lang ito. Kung ano yan, it is what it is, no? So, sir, paano yung 150 voltmeter? Itong part na to, this is ano lang, ano tawag ko dito? It's rating niya lang, no? So ngayon, rating, and it does not affect the reading. Kumbaga, sinasabi lang na yung voltmeter is rated at 150 volts. So, yun yung pwede mong i-install sa kanya, no? At ang nabasa niya is 118, kasi oo nga naman, this is rated at 150. Ang A natin, which is your EP over ES, equal yon sa VP over VS. If that is 20, that becomes what? The instrument deflection is 118, calculate the line voltage. Siyempre, dahil sa secondary ka nga nagtitest, 118 yun. No? So, VP is 118 multiplied by 20. Ayan. Thank you po sa mga nag-a-answer. Ayan. 2,360 volts. Okay, so that will be your line voltage. Yan. Tulad nyon, basa niya 118. So, tawag ko dito. Ang basa niya ay 118. So, we need to use the transformation ratio of that potential transformer para makuha natin yung tamang answer for that. Okay. 42. The potential transformer of outline have a ratio of 132,000 down to 66. Leads are connected in Y delta. The voltmeter connected at the secondary reads 64 volts. What is the voltage of the line? Okay. So, tawag ko dito, this is what? Y delta Y. Y, no? Tapos delta. Ayan. Okay? Sabi nito, no, the voltmeter connected to the secondary reads 64 volts. So that's line to line. Okay, so ibig sabihin, we'll have here the VS, which is the 64 volts. Okay. Now, kunin natin yung V sub T. Ngayon, ang A natin, which is equal to VP over VS, is 132,000 over 66. Is equal to VP over VS na 64. Okay? Now, tandaan natin na ang transformation is face to face. So 64 times 130,000 over 66. And that's 128,000. Hindi pa yan yung answer ha, that's 128,000 volts. Ganito kasi yun, ang pagkaka-read niya kasi dito is 64 volts. Ngayon, if that one is to be, sabihin natin, ito yung ka-connection niya, ABC, ito yun, no? Ang nakuha natin ditong VP is 128,000. Ang hinahanap niya kasi, what is the voltage of the line? Okay? So, let's name this one as VP prime. Okay? The VP prime is 128,000. But of course, we have to multiply it by square root of 3. Okay? Kasi that's the difference. Or yung what do you call that one? Yung multiplier para makakuha ng 3-phase. 128,000 squared. Which is 221.7. 221.702 in kilovolts. Okay? So, ibig sabihin, we have the letter A as our answer for that. Okay po? So, ganun siya gawin. Kaya tandaan natin, in instrument transformer, ang transformation ratio natin, sa bagay, kahit naman, sa bagay, o tama naman, oo. Face to face talaga lagi ang pagkaka-transform or nung voltages and currents. Okay, kunwari, phase current to the line current, phase voltage to the line voltage. Ay, phase voltage to the, sorry, phase current of primary to phase current of the secondary. Ganun din dito. Sa voltage, phase voltage of the primary to the phase voltage of the secondary. Laging ganun. Tapos yung line naman, if you want to get that, either mag-multiply or divide lang tayo ng square root of 3. Depende sa need, no? So that will be our answer in 4. Next to that one is number 43. The CT ratio and PT ratio used to protect the line are 240 and 200 respectively. If the impedance of each line is 10 ohms, what is the relay impedance to protect the line from fault? Ngayon, when you think about that, it's like, sir, but ganon, no? Why is that? Merong relay impedance to protect the line from fault. Kasi in as much as we use the instrument transformers to measure, no, we are using also them for protection. Ibig sabihin, may pinoproject sila na impedance, no? Ang hinahanap natin, what will be the relay impedance? Ibig sabihin, the ZR is equal to J line. Tapos, we are going to multiply it by the ratio nung, sabihin natin, ang tawag ko dito? Di ba impedance to? Potential transformer over current transformer. Okay? Ganun po yun. So, ibig sabihin, this becomes 10 ohms multiplied by, kasi tingnan nyo to, pag dinivide nyo yung potential to current transformer, impedance din siya eh. But of course, wala naman tayong impedance transformer. So, we understood that the ratio of the voltage to current is your impedance. And this becomes, tawag ko dito, no? Baliktad pala ako, sorry. Line pala ito, sorry, line. This is Z line, sorry. Z line to Z relay. Okay. Kaya pala sabi ko, ba't hindi ko napaikot yung formula? Kaya ibig sabihin, ang Z relay is equal to Z line multiplied by A sub CT over A sub PT. Yan yung gusto ko mangyari. Okay, laging ganun ha. Ibig sabihin, the Z line we're given as 10 ohms multiplied by ang ACT ay 240 over 200, no? And then the Z relay is equal to this 10 times 240 over 200. We have 12 ohms. Ayun. So this becomes the relay impedance to protect the line from fault. Yan. So tandaan natin yun ha, that the line impedance itself is the relay impedance times the ratio of potential transformer to the current transformer. This is 12 ohms. Okay, kasi we are going to multiply your what you call that one, the relay impedance to the ratio of ratio of potential transformer to the current transformer. So technically, it's like it's like Z percentage or Z per unit siya. Ganun yung dating. And of course, we need to get the Z relay. Kaya babalik na rin natin yun. So that's number 40. So next to it is this one. The parallel operation of transformers. So sabi dito, several important conditions must be fulfilled. Number 1, the voltage ratings of the transformer of both primaries and secondaries should be identical. Ibig sabihin, ang VP1 nyo is equal to VP2. Ganun siya, no? Second, the transformers must be properly connected with regard to the polarity. Yes, correct. No, kailangan yung magka-connect yung H1 to H1, X1 to X1. Ganun siya. Third, the equivalent impedances should be inversely proportional to the respective kVA ratings, which is normal naman to for the transformer. Tapos, the ratio of the equivalent resistance to the equivalent reactance of all transformers should be the same. Yes, isa pa yan. No? Equivalent equivalent resistance to the equivalent reactance. Ayan. So, ito yung apat na tinitingnan natin. And this is an example of transformer na nakaparallel. Pero madali lang naman ang computation nito when it comes to the distribution of kVA. Okay? So, yun lang naman, no? Sige. Let's proceed with this. Sabi dito, no, 125 kVA distribution transformer with 4% impedance is connected in parallel with another transformer rated as 75 kVA with 3% impedance. Both have the same voltage ratio. Yes. What is the division of the load when the total load is 140 kVA, 80% power factor? Okay. Ang tawag natin sa gagawin natin dito is by power divider. Tinawag natin itong by power division. This one is kamukhang-kamukha ng current division. Such that if you have two transformers in parallel, ang S1 ninyo is equal to the S total multiplied sa impedance ng hindi niya i-distributan Z2 over the sum of Z1 and Z2. At kahit percent impedance lang yan, okay lang. That's S1. S2 ganun din. S total times Z1 over Z1 plus Z2. So that's it. That's for by what? By power division. Okay? So ngayon, tawag ko dyan, with this, para lang siyang current divider, para hindi kayo masyadong mag-isip ng malalalim na formula. Now, it says there that the total is 140. Kaya po, ang S1 nyo is equal to 140 kVA multiplied by, what's Z2? 125 with 3% impedance, 0.03. All over 0.04 plus 0.03. Okay? So, ang S1 natin is set to be equal to 140 times 0.03 over 0.07. 60, no? 60 kVA. Okay? Now, ang S2 naman natin is as simple as S total minus S1. Siyempre, mapupunta na sa S2 yung mga hindi na-distribute from your S total. So that's 140 kVA minus 60 kVA, which is 80 kVA. Yun lang. So, ganun lang siya kadali. And maybe you're thinking, no, sir, paano po yung 125 kVA tsaka 75? Yung dalawang yon, no, yung dalawang yan, is only the rating. Ibig sabihin, it does not affect the distribution of the load. Ngayon, ang naka-affect lang sa distribution of the load is the impedance nila. Tawag ko dito, no, yung rating niya, malalaman lang natin kung overload siya or not. Yun lang naman po. Okay? So that's it, no? That will happen if we connect transformers in parallel. Ayan. Okay, next is number 45. Two transformers 1 and 2 are connected in parallel, supplying a common load of 120 kVA. Transformer 1 is rated 50 kVA, 7,600 240 down to 240 volts, single phase. and has an equivalent impedance of 8.5